Damn it.
Thanks for the bits, y'all.
Don't forget to like, share, and subscribe. Okay, we are good to go on the live sharing front.
All right, Rohan, whenever you're ready.
All right. Yeah, I guess I can go ahead and get started. All right. Can y'all see that? All right, cool. Yeah, I guess also feel free to hop in with questions like whenever you want, just so I'm not just talking, I guess, for an hour straight. Yeah. So, hey everyone, I'm Rohan. I'm going to be doing an intro to ML kind of workshop. How we're going to structure this is we're going to kind of go through, I guess, high level, different ways to like break down and frame ML problems. And then we'll kind of go through some cool applications of ML. And I think at the end, like, there's some resources for you to get started and also some cool project ideas, and also like we can like do questions. So if you have a project you're like currently working on and you want some more feedback, since this is going to be pretty high level, maybe you can ask specific questions about the particular use case you're looking at, and we can kind of help you pick a direction and go from there. Yeah. So why all the hype for ML? Well, it's kind of like taking off and like exploding in a lot of different like areas. So popular applications of ML like recently are like in the fields of like computer vision and like also automating some tasks that are considered to be like pretty hard, and then also like natural language processing. You also see like applications and things like assisted like machinery for surgery. Up here at the top left, we have like face detection, self-driving cars. We have chatbots down in the bottom right. And then we also have like things like spam detection or like, log filtering or stuff like that. That is like, very manually, very labor intensive that we can start to automate by using machine learning. So yeah, those are just a few of the applications. We'll dive into some more later. And I guess we'll start with kind of like, how do we frame an ML problem, like starting from scratch? So I really like this graphic because I think it like kind of breaks down the like general field of ML into like three big categories. We have supervised learning, we have unsupervised learning, and we have reinforcement learning. And in this presentation, we're going to get particularly into supervised learning and unsupervised learning, since those are pretty like common in, I guess, application. And then within supervised learning, we have two different kind of topics. We have the topic of classification, and we have the topic of regression that we'll be going more in depth into. So what does like a standard ML pipeline kind of look like? So you have kind of four different I guess aspects to this pipeline. The first thing you need is the data, which is like, what should our like model at a high level learn? What is the problem we're trying to solve? For example, are you looking at tweets and like trying to classify sentiment? Are you looking at particular dates throughout the year? Are you trying to predict the temperature for that particular date? Are you looking at something like census data, which is like pretty unstructured and has like a lot of fields and stuff like that? And it's kind of like, what do you want to do with your data that you've kind of collected and harvested over this period of time? The second part is kind of the model that we talked about. It's like, that's kind of, I guess, a little more self-explanatory, like what the model kind of is. For example, popular models are like neural networks, statistical models, like what is the thing that you're trying to use to like look deeper into the data and make predictions about the data? What is that whole like algorithm side look like? The third kind of aspect you need to like automatically learn these things is this thing called a loss function, which kind of helps evaluate how the model is doing. So how well does the model fit the data you're looking at? Does it get a lot of things right? Does it get a lot of things wrong? How can you automatically measure this? Some common loss functions would be like looking at something like mean squared error or like cross entropy loss. But those are like further technical details that we'll get into in the future. And then the fourth kind of component is an optimizer, which is like, how does the model get better? You have like a scoring for this model. Now, how do you actually learn it, and how do you like get better at getting higher and higher scores? So this is where you hear things like SGD, like stochastic gradient descent, or like just gradient descent in general, for like learning the score function to have your model better fit the data. So that's kind of how all of these factors like fit together to like create this whole like ML pipeline for learning and fitting your data with a model, which is exactly what you're doing with machine learning. So I guess if anyone has any questions, like feel free to hop in or like interrupt me at any time. But I guess I'll go into like the first part of this like whole pipeline, which is kind of the data set. So first and foremost, like when you're working on an ML application, the first thing you should do is like identify a data set for your application. You kind of want to make sure your data is relevant to the end goal and like learning the things you want it to do. And so you'll employ techniques like collecting the data, cleaning the data, and normalizing the data. And those techniques are like often non-trivial. You'll find like plenty of like research papers and data sets out there kind of explaining why, what problems exist in their data and also like how they collected their data. So the first thing you should like do when you're like working on these applications is, like pick a problem and find a data set that like reflects that problem, like reflects that problem. And this can either be like hand labeled or it can be like automatically generated. But first and foremost is having a large enough data set to have a model that can learn things meaningfully. Yeah, and I guess libraries like pandas and stuff like that are useful for curating these data sets. That's kind of like this picture we have down here. Once you have like kind of acquired the data set, you typically partition it into like 3 different sets. You have a train data set, which is used to actually like train and the model that you evaluate the loss on constantly, and you like optimize to get your model's performance better and better and better on this training set. You have a development set, which is used to like fine tune the model. And then you have a test data set, which the model never kind of sees in its whole training development pipeline. And that's kind of used to evaluate your real world performance of your model to get kind of some insights into how this thing might actually behave. Yeah, so that's kind of like the whole like data set side of things. You identify your problem, you collect some data to like try to solve that problem that you want your model to approximate, and then you kind of split it into these 3 sets for the entire training loop. Does anyone have any questions on that?
We have a question in the chat. Brady's asked,
cool.
How much data is enough for some of these models?
Yeah, so I guess it depends on what problem you're trying to solve here, right? Something like, I guess, computer vision, like you'll probably need thousands of examples for something like object detection over multiple classes or something like that. So how much data is enough? More data is always better. But sometimes like you can look at how your model is performing on the train set and seeing like, if there's like a huge disparity between your train set and your test set, you might be like overfitting to your train set and you might need more examples in your train set or to like augment your training set to like have more data or something like that. So typically like it depends on the use case. And I guess like if you have a specific use case and you're not sure, we can always like talk about it. Yeah. Yeah.
One more question in the chat. Someone says, I am using pandas, open PyXL currently in my code to read the Excel sheet data. Can I read/play with that Excel data using these models more efficiently?
If you're using pandas, I think that generally should be pretty optimized. I think libraries like scikit-learn like use pandas data frames natively for optimized like playing around with different models. So yeah, we can get into that library as well. I think we'll get into it later, but yeah, definitely recommend using pandas. And then if you're using a different like framework like PyTorch or TensorFlow, where you have more finer control over what the actual model is, using the pre-built data loaders is usually a good idea for optimizing how to load in data and stuff like that. Yeah, I don't know if that answered the question or if there's a follow-up.
Thanks, it does.
Okay, cool, yeah. Yeah, so now we'll kind of get into this next part of the problem, which is like, what kinds of learning kind of are there? And each of these kind of like varies the pipeline a little bit in terms of what model you're using, what the loss function you're using is, and what optimizer you're kind of using. So the first use case, like if you remember that big picture we talked about, is we're going to get into supervised learning. And what's important here is that in addition to the examples, you also have corresponding labels for each data point in your data set. So for a given input X, we're going to use a model to try to predict some label Y. And then we'll define like that same goodness score using a loss function. And then we optimize the model to get better and better at learning this loss function. So how does this kind of like relate back to the ML pipeline? The loss function should now compare like the output of the model to like what the labels are. So that's one big thing. And then low loss ideally should correspond to like high correlation between the labels and the model output. So we're going to try to minimize the loss and get the model to match the labels as best as possible. Is kind of the overall goal here. Let's get into some examples, I guess, of supervised learning, which we said we could kind of break this down into classification and regression. So the first thing we're going to talk about is like prediction and classification tasks. So we're going to predict an outcome for the future based on the past and present information. But the important thing in classification is the output label Y is a discrete class. So for example, a binary like output decision, so like a yes/no question, or something like sentiment analysis, is it positive or negative sentiment analysis? There's a discrete label kind of given to each example that we're going to try to learn. These can also be multi-class. So for example, object classification, like for a whole image, you're trying to predict basically for an entire image, what object is kind of like there. Like OCR digit classification. So let's say you have handwritten digits and you want to classify like what digit is actually written. That would be a multi-class task. And some models for kind of handling this, some typical models, you can use like a perceptron, multi-layer perceptron, or like a feed-forward neural network, CNN, a convolutional neural network, an SVM, logistic regression, and like the list kind of goes on and on and on. And there's multiple ways to like kind of customize these supervised learning tasks with labels. You can use a library like PyTorch to define your own neural networks and stuff like that. Or you can use like some pre-built SVM libraries in scikit-learn, etc. So yeah, that's kind of like one aspect of like the whole supervised learning at a high level. Like there's this classification side where you have discrete labels, and that's the important part. And then we also have regression. And again, like the goal is the same. We want to predict the outcome based on present and past information. But here, oh, oops, this should say continuous class. My bad. We want to predict like a housing price or a temperature. So like we want to predict something that doesn't fall into discrete classes. We want to predict something that falls into a continuous class. So over like real numbers. Or so in this case, like something like linear regression or polynomial regression would be like a good model to use here. Yeah. So I guess we'll do a quick example here, regression or classification. So yeah, what are your thoughts? Predicting market data, is that like a regression problem or is it a classification problem? What do y'all think? Let's say the output is like you have like some stock price or something that you're trying to predict. Yeah, great. I see a couple answers for regression, and that's 100% correct. Yeah. What about something like spam detection, identifying if an email is like spam or not? Would you all say classification or? Okay, yeah, great. I see a lot of classification. That's 100% the right answer. Image classification. We have like, okay, yeah, I guess that one kind of gives it away a little bit, but yeah, I see some more classification in there, and yeah, perfect, right. And forecasting temperatures. Yeah, and then I also see a question, so we'll answer regression real quick. One, yeah. So this is also regression. Yeah, so regression, the idea is you have like some input labels X, and you have some output Y. But in the second case for regression, Y is kind of continuous, meaning that like it's going to be a scalar. If you're close to the right answer, that's still considered a pretty good prediction. Right, so let's say you're trying to predict the temperature of, and like tomorrow's temperature is like 65 degrees with some model that takes in like maybe the current date. And your model outputs like 65.2 or something like that. That's still a pretty good prediction for tomorrow. So you can kind of evaluate how close you are to your label using the distance kind of between these things. So yeah, so exactly. In like regression, your output is kind of a continuous function. So yeah, and there's a discrete data, but the model prediction uses a continuous function. Ami, that's the right idea. Yeah. Yeah. Does that make sense for kind of what regression is? To answer that question. Okay. Cool. Yeah. Yeah. So now we'll get into like supervised learning, this whole branch of things. So there's no corresponding label for each data point X in this case. We want to kind of use a model to fit input data on itself and do some like further data like inspection and like inspect the actual data itself. And we want to understand like different properties of the input data distribution. So here, instead of trying to predict some label Y, we're trying to understand X at kind of a more fundamental level is how you can think of unsupervised learning. So how does this kind of fit into our ML pipeline? So here, like, I guess loss gets a little more tricky. It kind of depends more on the algorithm itself. Most unsupervised learning algorithms do indeed optimize the loss function, but the loss function usually compares the model output to like the original data. And the optimizer used is usually mathematically proved to be making an optimal step forwards in terms of its optimization. And you typically won't have to implement this step unless you're doing something fancy like the whole optimizer and loss function. Typically with unsupervised learning algorithms, there exists a really good library that already handles this part for you. So scikit-learn for like k-means or something, or k-nearest neighbors, like that kind of handles that whole part of it for you. You just need to pass in the data and it'll inspect the data and output some optimal parameters for your model. So yeah, that's kind of like how unsupervised learning kind of is. The idea is you want more insight into the data itself. That's kind of the big idea here. So we'll look at a few case studies to kind of understand what's going on. So some common tasks are kind of like, let's say you have a bunch of data and you want to like split it into different clusters automatically. So that would be a common like unsupervised learning task, since you don't have any labels for how these clusters should be kind of set up. So that's kind of seen in this bottom left image. We have like this data that's kind of grouped into like 3 clumps, and we want to like automatically learn which cluster each thing belongs to. So that would be like a k-means application of like passing in your data and like learning where all these clusters are. Another common task is anomaly detection. So let's say you have a bunch of data that is all centered around like one kind of point, and you want to kind of automatically detect when something falls out of some radius of this data. So that would kind of like be one use case for unsupervised learning, since you don't like really have labels for what is an anomaly and what isn't. You're looking for like groups of where data is similar and groups of where data is like dissimilar. Language modeling is, I guess, another like unsupervised learning task. The idea with language modeling is you want to learn what words kind of come next after a previous context of words. So we see this use case in this top right kind of image, where we're trying to use the previous words to predict the next one. So that's kind of an example of unsupervised learning, because you don't really have labels for what the next words are. You have like a block of text, and you're trying to extract like the next word from that kind of block of text. There's no like corresponding label for what we should learn. And then another use case that's kind of like a little different is dimensionality reduction. So in this case, we see this in the bottom right example here, where we have like all of these points like kind of in a 3D space, and we want to project them down into a 2D space to see if we can automatically identify clusters like easier. So that's kind of a process known as PCA. And another application, I guess, more grounded in like the real world of something that I worked on in the past was we had a bunch of like census data for like blocks in a city that were like considered pretty gentrified, and we wanted to identify what factors kind of led to this gentrification, I guess, from census data. So we had like this huge like input representation for what census data is, and we wanted to like compress that down to like maybe a handful of features to see like what is common kind of between these like blocks experiencing a lot of like gentrification. So that's like another example of dimensionality reduction. You have like lots of features, and you want to compress it down to maybe a few features that kind of account for a lot of what's going on in the original data. So some common models here are like k-nearest neighbors, k-means, mixed Gaussian models, PCA, and the list kind of goes on. And if you're doing something with unsupervised learning, I think scikit-learn is going to be your best friend here, because they implement a lot of this automatically, and you can kind of look to see what your use case is and what might be a good model kind of to fit your problem is. Yeah. Are there any questions? Let me check the chat real quick. Yeah, so I guess what math classes should you take to have the background for these? I think linear algebra and like statistics, like a introductory statistics class is kind of what would be a good fit here. At UT specifically, there's also a data mining class and an advanced data mining class that kind of goes through more of these unsupervised learning algorithms, which I think have been fantastic. Highly recommend taking both of those classes as well. Yeah. Cool. Yeah, and then this is kind of unrelated. This is, I guess, a general ML framework that's kind of become popular in recent years, which I think is also really useful for, I guess, more application-based AI. And this is the idea of like transfer learning. Oops. And so this is kind of a critical component for scaling AI. The idea is you have like a huge data set that you pre-train a model on, like using like dozens of GPUs and computers. And the idea is like once you have like this trained model that's pretty general, you apply it to your specific use case through a fine-tuning process. So the idea here is like a lot of big companies, like at least I can speak to the NLP side of this. So a lot of big companies like Facebook and Google have like pre-trained some really, really massive models on like gigabytes of data. And they're kind of like working on like open sourcing these models and allowing like you to build stronger models using what they have kind of done as a pre-compute kind of step. So the idea is you take one of their huge models and you apply it to whatever your specific task is, because it like has trained over this huge corpus of data or this huge data set, and ideally generalizes pretty well to like whatever your end use case here is. So the advantages here is it saves a lot of time and effort. It allows AI to kind of scale and use it more user accessible. And then you kind of get like the advantage of like the state-of-the-art performance on your end goal tasks, assuming like your end goal task like fits the original training data set like pretty well. So yeah, like most AI libraries do provide these pre-trained models that you can kind of use, and yeah. Yeah, so that's kind of like the whole, like, I guess, more technical side of things in terms of like, how to get involved with ML and like how are different ways you can kind of think about these problems. Now we'll kind of dive more into like what are specific applications you can use here and talk about that at kind of like a more like high level, and yeah. So the first kind of big application we'll go over is computer vision. And the idea behind computer vision is we want to like acquire, process, recognize, and understand visual data. And some like libraries and like tools we can use here are like OpenCV. Neural nets are very popular here. So like CNNs are a special type of neural network that are used to process images. And then OpenPose is also another popular library. So I think OpenPose allows you to like look at poses of people. So if you wanted to like detect like, I guess, what body configuration, I don't think that's the right word, someone is standing in, and kind of like detect where their limbs are and stuff like that in like a image. That's kind of like what OpenPose would kind of be used for. So this is kind of the first big like subsection of like ML we'll kind of dive into and look at a few particular tasks. So here at the bottom, you can see this is the task of like semantic segmentation, which is the idea is for each pixel, we want to like determine what like object is like contained in that pixel. So you see like we have highlights over each like object. So you see like the cars are all in blue, the people are all in green. And then we also like create a bounding box around these objects to kind of like identify like which regions of the image these things kind of exist in. So I guess like one of the first like I guess projects people usually do with vision is this idea of recognizing handwritten digits. And there's a very popular data set called the MNIST data set. And it's a bunch of like handwritten digits and corresponding labels. So the idea is you want to feed in an image to the model and learn some features to like predict like a digit value. And there's a lot of tutorials out here. I've linked a bunch of them. I think these slides should be like available, right, to people. Yeah.
We'll make them available afterwards.
Okay, cool. Yeah, so you can definitely like go and click through these and like look and see like what's going on here. Yeah. So yeah, this is kind of like, I guess if you're new to ML, I would definitely recommend starting with a project like this, because this will kind of expose you to the entire like train loop, developing model, following along with like how the task of like supervised learning like is actually structured. Yeah. Also, yeah, I see in the chat there's a 3 blue 1 brown video. Also recommend that channel. Great stuff for neural nets and also like just general like math stuff. So yeah, highly recommend checking out that channel. Another problem, I guess, that's currently being worked on in the field of computer vision is face detection. So I guess earlier techniques look for different gradients and different like handcrafted heuristics for looking for faces. And newer methods rely on like this whole like neural net revolution and SVMs, and like looking and applying like CNNs to kind of images to kind of like automatically detect faces and stuff like that. So yeah, again, we have some more links down here, tutorials, and then also like in Cloud API, I think Google Cloud has an API to kind of like do automatic face detection too, that should have some docs on how to use it as well. Yeah, and then there's this other cool application, which is style transfer. So the idea is like we have like some sort of media that's like a source, and then we have some sort of style image that's kind of like what we want to transfer into that source. And the idea is like we encode that style image using a style embedding and feed it into a model. And we have like an input image that we also feed into this model, and we output like some combination of the two. So you can see some like really cool pieces of art that have been generated here by something by a style transfer model. So yeah, there's a link to a cool demo here. And then also, I guess, some more implementations for how to actually go about doing this in both Keras and PyTorch. Yeah, I haven't played with this demo before, but maybe at the end we can like go through and like just go through a bunch of these demos and like play with it. Yeah. Yeah, so I guess here's some additional resources kind of on Vision. So there's a list of everything, data sets, links to research papers, a bunch of tasks you can kind of play around with. There's a bunch of APIs also out there. There's like the Google API, Microsoft API, Clarify. Yeah, there's like really a lot of, I guess, kind of resources out there to like actually play with like these state-of-the-art models. There's this open pose thing that I mentioned earlier for pose detection. If you have like, I guess, if you're working with like a camera and stuff and you want to like detect people, that would be like a really good library to look into. And then there's also this GitHub repo, I think, that's for face tracking and recognition, made for a previous hackathon that I think worked. Yeah. Yeah, so now I can move more into natural language, which is another like big application of AI, and I can speak, I guess, more to this one. So this is like a field of AI. It's like concerned with how do machines interact with human languages. So it's like a mix of both like linguistics as well as like machine learning, and like trying to get models to comprehend and understand human language like much better. And that's a pretty tall task, because if you look at the use case of at least English, where most NLP resources are devoted, English is a very like vague language, and so having neural models to kind of like detect what's going on and reason about text is like a pretty tall task. So it's widely used in modern life. You see like applications constantly being released, like Apple's Siri, Microsoft's Cortana, Amazon's Alexa. There's a bunch of others that are like I guess Google Home as well, that are like kind of pushing towards like having more human interactions with their pieces of technology. So yeah, that's kind of one way you see NLP like being brought more and more into our daily lives. Yeah, so I guess like we talked about MNIST as kind of like a first step in computer vision kind of project. In NLP, I guess the equivalent here is like sentiment analysis. So the idea is you want to like take a sentence or a paragraph and identify like how did the user feel about this particular, what sentiment is the user trying to convey here. So cloud APIs, there's plenty of them out there, and they're very easy to use. And I guess a standard data set for doing this is the IMDb data set, which is basically given a movie review, you want to try to predict what kind of sentiment is being output here. And then there's also like standard Python natural language libraries, such as NLTK, which is the natural language toolkit, that have sentiment analysis also built in if you don't want to like go through a cloud API and kind of develop things from scratch. And then if you want to get even more hardcore about it, you can also like develop a model in like PyTorch and try to like output predictions using a neural net or something like that. So yeah, those are some cool resources to kind of get into sentiment analysis. And then if you want to take this and like make it even more complex, there's also this idea of like finer grained sentiment analysis, which is like we have more than just positive and negative emotions. We want to like find some finer grained like characteristics. So like, is it joy, or is it like I guess I don't know other words that mean like happy, I guess. Like joy, or like excitement, or like I guess anxiety, or like what kind of like I guess if like a text appears to be very like hyper, or like with a lot of like features like popping out at you, like what kind of like hyperness is being like employed here. So there's also like a few data sets that employ like this finer grained sentiment analysis that are also like somewhat challenging as well, that you can kind of extend this out to. There's also like named entity recognition, and the idea here is you want to extract some names and like some like I guess proper nouns from a body of text. And like identify these actors and the relationships between these actors. So there's some useful packages such as Stanford's NER module. I think that one is all in Java. There's the NLTK NER module, which is all in Python. And then Stanford also has a new one called Stanza, which is also really great. I think that's PyTorch backed and also in Python. And then there's other neural modules as well to like play around with NER. It's useful for information extraction as well as for creating models for user interaction. And here we kind of see an example of the output of an NER kind of model. You have like people that are output as well as like organizations and locations. So you can kind of like automatically extract data from like these unstructured pieces of text, which is super cool. Yeah, and then I guess if you want to go one step past this, there's like tasks such as coreference resolution, and you can also kind of like start to build graph interactions between the people and like objects in a sentence to kind of like understand at a more fundamental level how these like detected entities interact with each other, which is I guess a more complicated task if you want to like extend this further. Yeah. Let me also check the chat real quick to see if there's any questions. Okay, cool. Does Google have any named entity recognition? I'm not particularly sure. I haven't worked with the Google Cloud API all that much. I have worked with the Stanford module as well as NLTK as well as Stanza, and I found that they all worked pretty well. But yeah, yeah. I think Google probably has something related. We can look into that, I guess, after the presentation, and we can look for resources as well. Yeah, unless anyone knows in chat and wants to like say, but yeah. Okay, cool. Oh, they do? Okay, cool. Yeah, and then we have this like cool task that is kind of the combination of NLP and computer vision, which is image captioning plus visual question answering. So the idea here is like you have an image and you want to like produce some like caption for what's going on in the image, or like you have a question about the image and you want to like kind of answer it. And there's some cool state-of-the-art models. If you're looking into something like this, I'll look into LexSmrt, which I don't know if that's publicly released yet, but I'll take a look, I guess, right after this presentation for that, which is a cool state-of-the-art model for that. Yeah, so there's like kind of like combination tasks with both of them where you're both trying to use images and like natural language to kind of like do some cool stuff with the output and like create some cool representations. So another cool task that's I think probably worth looking into as well. Yeah, and then I guess for transfer learning and NLP, there's a cool library out there that I would also recommend you check out if you want to do a more NLP kind of project. Hugging Face is a company that has released this Transformers repository, which is an open source repository for pre-trained models, both in PyTorch and TensorFlow. So there's like a laundry list of like cool models that you can like look into and like pull and use for yourself. So you can leverage kind of like the pre-trained stuff Google and Facebook and like all these other companies have done. And then there's also like implementations of like the transformer stack, which I guess the transformer is this really cool new hip craze in NLP that's been doing really, really well since 2017. there's a PyTorch implementation that you can kind of look through, and then some visualizations of what's going on, I guess. If you want to like do some more stuff with NLP, like at a more complicated level, and like look into some of these more complicated tasks, I think these resources are really good. Yeah. Yeah. So here, oh, perfect. Yeah, we apparently have the Google Cloud entity detection like in these slides. Okay, cool. Yeah. So there's some cool demos here as well. Alan NLP also does some really cool stuff with reading comprehension with this demo. And then Google Cloud has like some entities, some entity detection, and also like sentiment and syntax categories for user entered data. Yeah. So yeah, and I have a couple of cool project ideas. I don't know if y'all still are looking for ideas and stuff, but some cool ideas could be like to look at a social media feed of a person and connect them to other similar users based on like a sentiment profile. Body language tracking using OpenPose for physical therapy or other tasks is also something that'd be pretty cool. You could look into something like an American Sign Language translator. And then I guess there's another GitHub link to like a base version of this project. There's a fake news detector, which can be hard to make, but you can, there's a bunch of, I think, sensationalized news data sets out there that you can look into and maybe train a model to look at. And then I guess in the spirit of all the debates that have been going on recently, a real-time fact checking, which is also like a very hard thing to make, kind of like looking at a claim and analyzing like whether or not this claim that is made is actually real or not. Yeah. Anything on CNN fake news? Yeah, so the difference between entity and sentiment is kind of like the user emotion that is kind of perceived in the text itself. So like if you read a movie review and it just says, I hated it, that would be like a negative sentiment, or like I loved it, that's a positive sentiment, right? Entity would be like identifying the people or like the places or like the things kind of in a piece of text. So for example, I walked to the store or something, like the store might be a location that you like identify. That's kind of an entity that occurs in this text. So you can think of them as like nouns or proper nouns kind of thing. Yeah. I hope that explanation makes sense. Yeah, so yeah, the idea is like you want to break down this piece of text. So like there's two ways to do it. You can either understand like the intent that was behind the text, or you can kind of understand what are the things that are going on in this text. So like the things that are going on in this text are like entities, and then the understand what is the meaning and emotion behind this thing would be sentiment. Yeah. So just like more detailed look into like what's going on here. That's kind of the idea for both of them, but like they go about it in different ways. Yeah. Cool. Yeah. Any other questions? And then there's also like a laundry list of resources at the end to kind of stuff that's worth looking into if you want to do something like this. So I guess general ML tools, if you want to like develop a model, scikit-learn, PyTorch, TensorFlow, and Keras, those are going to be your big four that you want to look at. Pandas for like processing data and like feeding it into the models could be good, especially with scikit-learn. I think that's a pretty common stack. NLTK is also very popular for natural language. And then there was also like Stanza and Stanford NER, which aren't, I guess, as commonly used since Stanza is new and Stanford NER is Java backed and not Python backed. But yeah, pose estimation, OpenPose, that's worth looking into. APIs for general ML tests. Microsoft Azure, I think, has like automatic transcriptions and stuff like that too. Google Cloud Vision, like there's a whole bunch of them. Many of these cloud services will have ML, NLP, and computer vision kind of backends as well. And then also highly recommend looking at like Kaggle and Stack Overflow. Kaggle will have a lot of data sets as well that you can probably pull from as well for your particular project. And yeah. Yeah, so I guess, is anyone working on like an ML kind of project and wants to share, I guess? Or I don't know if that's allowed, or if there are rules here.
Good. Feel free to share. Then we can like kind of point you to resources that would be solid for your project or anything we know of that exists.
Yeah.
Just drop it in the chat. Or if you're like thinking of using something but you're not sure where to start, also a great place for this.
Who are the two faces that keep appearing on the slides? Yeah, I think this, so I didn't know actually for a while until I reverse image searched them. Apparently this is a paper from NVIDIA that are merged representation input faces. So like these are not real people. I think they're generated from a model, which is kind of crazy. Yeah. Yeah. Also highly recommend taking neural nets. That's a great class.
Wait, who teaches that class again?
Some weirdo.
We also don't have to talk about ML. We can talk about other things too. How's y'all's days going?
Great, Rohan. How's your day going?
It's going well. It started a little more than an hour, a little less than an hour ago. Yeah.
Oh, respect.
Yeah. Yeah.
I will take us off of live and then